Tutorial series where we're using the Swift programming language and the NIO framework to create a MUD-based game. And today we'll be working on setting up our user database. So we'll make the first step where a player who connects to the server will be able to create a user for themselves. And this will also be the first time we're tackling asynchronous code, because saving data to a database is of course very much I/O bound and an excellent case to introduce asynchronicity to make sure that we block our event loops, the few we have, as little as possible. So how do we do that? Well, first off, we're not going to be using an actual RDBMS system such as Postgres or Mongo or SQLite or something like that as our database backend. We'll create more or less a stub and that will allow us fast iterations, but still give us an API that's very easily transported or transformed into using an actual database. So I'm choosing to write a sort of database backend here from scratch, and to give an idea about the async await based features in Swift 5.5, and also have a backend that's very easily debuggable when required, and we'll set it up in such a way that it will be easy to transform it in something like Fluent or MongoKit or any other database, or perhaps even backend service out there. So let's start with creating a new Swift file, and this will be hold our user struct, and for now that's going to be a very simple user. Our user has an ID, it has a username, and it has a password, and of course this should be a hashed password, but for now we'll just store the plain text password and imagine that it's being hashed. This is not something you want to do in practice, but for now it will be good enough. So this is a user structure. When it comes to the kind of API that we want to have, then we want to do something like, for instance, say I want to find the player. I want to do something like user.find ID for a certain ID, and somewhere I already have a player ID, and that should return our player. And because this will be an asynchronous function, we want to do something like that. And there should be on the user should somewhere have a static function called find for a UUID that might return a user, or nil if one can't be found, and this will be an asynchronous function. And this pattern where you use a static member function to search a database of a type is a pattern that's used in Swift object relationship models quite a lot. So that's what we're going to mimic here. So what we need is some form of backend storage, and what we want to do is we want to save that storage as much as possible using codables, so we have a file on disk that we can also inspect. So let's say we have here a static member variable that contains all the users. I will make it private because we don't want users to interact with it directly. So we have all users, and this needs to be of a certain type, and yeah, we need to create a database. Let's give it a name. We'll call it our AwesomeDB. And this will be a generic. And this will have an initializer. Of course, AwesomeDB doesn't exist yet, so let's start building this one. And this database will create as an actor. And an actor is a new type in Swift 5.5. And an actor allows multiple threads to access the same object and make sure that there are never locking conflicts, or there are never any race conditions or other typical bugs that you can find in when working with multiple threads. So it's a sort of an object. It's a reference type, but it's thread safe. So that's really cool. The one thing that is important to understand is that an actor, when you want to access data from it, you always call asynchronous functions, because they're put into a queue somewhere in a backend and then processed. So it doesn't exactly know when the answer will come, and to prevent any locking or blocking, interacting with it is mostly using these specific functions, or using asynchronous functions. So we have AwesomeDB, and the AwesomeDB will be a generic, and we need a sort of type or protocol for what it's able to store. And I think we should have a DB type, and it should conform to Codable. And my only requirement will be that it has some unique identifier of type UUID that we can get. So now we can say that our AwesomeDB contains DB types. A database type, and that will be of type DB type. And the database type is the one that we can reference as a placeholder in all the functions we're going to put into the actor. Xcode immediately helps us, saying user does not conform to the protocol DB type. No worries. We can just add that. And because the only requirement is already fulfilled, having an ID variable, that's enough for now. Our database will have, we should tell we're targeting macOS 12 and higher only. Always need to look up the exact syntax in package in Swift Package Manager, how to set up OS requirements. Let's see, so we have our name, then we can have platforms. It'll be an array of supported platforms, and one will be macOS, and I think V12 is the one that we want. I'm missing a separator or something like this. I have our name, I have our platforms, I have dependencies, okay, so we're not done yet here. So we have our we need some form of storage for a database, and let's see. So we need a private variable storage, and this will be of type database base type. And what we will do is we will load it. We'll try and load it when we create the object. So we'll create a static function called load storage. Let's do that now. A private static func load storage, and this will send back an array of database type. Now we need some. We need to find a file. So we'll first check whether the file containing our data exists, and we somehow need to have a file name. And what will our file name be? I think it would be nice if the file name, say if you have something called, say the type is user, then the file name will be users.json. Or if the type is room, the file name will be rooms.json. There's a trick to getting this data, and we can start by creating a static static computed property that takes a database name and plus .json, and the database name can also be a private static variable. And this one will use string interpolation to get the database type dot self. So we get the type name as a string. We'll transform it into lowercase, and we'll add an s. And we now have the file name here, and this works because when the Swift generics substitute this name during runtime for the actual type that we're storing in this database. So we have a file name. Then I want to make sure that we can decode it. So let's create a decoder, a JSON decoder, and we'll return try decoder.decode of an array of database types from the data that we get. Oh, wait a sec. We have a file name here. Oh, we first need to make sure that we get some data from it. So we have a file manager, default, contents, add path, file name. So we first check whether the file is actually available. If it's available, then we try and read it and get some data from it. And we have when we have the data, we try and decode it into an actual data type. And we need to catch any errors due to the try block here. And what we'll do is we'll simply say print error reading data, and let's just see what's going on. And if that doesn't work, or if for some reason this file doesn't exist, we'll just say we'll print out that we can't find the file, and we'll return an empty array. So if everything goes according to plan, here we're bailing early and returning the loaded database in type in array form, and if not, we're simply returning an empty array, which means that anyhow this will always be initialized. Let's see, do I miss a bracket somewhere? Okay, so now we have a database. Now let's see if we can create a user. Let's say we want to save some data of a database type. This will be our first asynchronous function, because what we want to do is somewhere here, when the user is created, we want to have our created user and say save, and be sure that it's saved to persisted to disk correctly. This is what we're doing. We're going to save it, and what we're going to do is we need an encoder, and we'll set the output formatting to pretty printed, so we can easily inspect the output if something unexpected pops up. We transform the storage into data, and we'll get a URL for the file name. We'll say try data.write. We'll write the data to the URL. And we'll say print save the data to file to this URL. And if something went wrong, we'll print out the error. What we also need to make sure is that this one is just saving anything that's in the in the array. We also need to be sure that we can add or replace an object. So we'll replace or add database object and this will be an asynchronous function, and we'll first let's see if there's an existing object. This is an object but an index, and we'll set it to the new value of the database object, or else we'll just add the new database object. Okay, so this is a lot of ceremony, and is probably not the clearest code to read, but let's see how we're using it, and I think that will make it a bit more obvious. So we have a sort of a database backend here. We now only have options to get data into it. We're not really reading it out yet. We'll add that later. Let's see how we can use it. So we already have our all users property of our AwesomeDB type for the user type, and user conforms to the protocol that the AwesomeDB requires, so that's fine. We instantiate the all users property as a new awesome database, and that also makes sure that it tries and load the data, even though none exist at this time, but it will in the future. So let's try and create some methods to help actually create a user. So let's say we in the end we want to do something like user.create user and then username, full and password bar, and everything should work. So we'll have a static function create for a username, a string, and a password, also a string. And this will be an async throwing function, and it will create and give back a new user. And the reason we're using throwing function is because we want to check whether a user already exists with this username, and we'll want to send out an error if the user already exists. So we'll have a user, we'll filter on the username, and now I remember we don't yet have a filter function, because we'll add it momentarily. And this should be nil. None should be found. If one does, we'll throw an error. We'll say we'll have an enum user error of that conforms to the error protocol, and we'll have case username already taken. So there'll be a user error, username already taken, and then we can catch that error later on and make sure we print out a nice message. Let's say no user exists yet, so we'll create a new player. I will create a new user for username, and that with a hashed password. We'll hash it later, no problem. And we'll create a user with new ID, and then we'll await player.save, and we'll return the player. Let's see. So now we need to create our missing functions. So our user type has no member called filter. We can't yet filter on user IDs, and we can't yet save because our player type doesn't have a save method. So let's create these two methods. So let's create a filter method first. So we have a static function called filter, and we'll filter on the username, and this will be an asynchronous function that returns perhaps a user if it can find one. And this one needs to look into the all users array and see if it can find this this user. Actually, we want the first user. So we want the first of a certain username. So we want to have the first one that's that fits this one, and we'll say where the username equals the username that was passed in. However, our all users is of type AwesomeDB, and that doesn't have a first method yet. So we need a first method here, and we'll create it as a predicate, and this will be of let's see, it will be will take a function and that will take a database type and send back a bool value. And this might send back a database a value of database type, and then we can just do storage dot first, and we can send in the predicates. Then we have user name. His name. Sure. So that should take care of the first error, because we're now able to find users. The second one is we need to save, and the save method will be that one will be an instance method, because we want to be sure that we tell which one to save, and this will be pretty simple. We'll have a function called save, an asynchronous function, and we'll await. We'll first add the new user, and then we'll save. And I don't think we actually need this one here, because we're always saving out the entire array. Okay. So we have, let's see, we request, we have our user here, we saved it. There's a lot of work. Let's see if we can hook it up into our system. So we first need to have a command to create users. So let's say we have a command called create user, and this one will have a username and a password. Now we somewhere here need to add this case. So let's say the correct command is create user, and we'll return a create user. But we somewhere need to get a username and a password, and we can't just use parts 1 and parts 2, because we haven't checked whether these will actually exist. So we need to check whether we have enough parts as required for this command. So we should get create a function that returns the expected word count for a certain verb of type string, and this will require an integer. And we'll switch on the verb, and we'll say case create user, and this one requires 3. And for all other cases, for now, we'll just say we return 1. And we're creating a user requires 3 because the first one will be this command, the second one we assume will be the username, and the third one we assume will be the password. And if we here guard that the parts.count is at least as large as the expected word count for the verb for the first part, then this we should be this should always be true if it finally gets this one. If it doesn't, we'll just return an illegal string because we don't have enough words. So we should now be able to get back the create user verb. However, our parse handler is not yet equipped to handle this specific new command. So we can add a new one, a case for create user, and we'll get the username, and we'll get the password, and we need to use this to create and save a new user. And this is a bit more tricky because, well, let's say we create the new user. So we'll just give it, we already created this method for that. So we have a username and a password. And we'll return, we'll create a response for a session, for updated session, and a message and new user.username. Okay, let's try and build this, but it fails because we're calling an asynchronous function. First thing, we need to add the await command, but it's still not happy. Apparently it's also a throwing function, so we should also make sure that what's the easiest way of doing this? Well, let's say we try. It requires this to be in a do catch block. If it doesn't work, we'll send back our and we'll just send our error. Okay. But now we come to the final issue, and that's we're trying to call this asynchronous function from a synchronous context. So we somewhere need to bridge from the synchronous channel read function to our asynchronous world, and the easiest way to do that is to use a task. But we can't only wrap this specific function in our task because, well, let me just show you. If we do this, it does not allow us to change these variables that were created in a context outside the specific task. So it doesn't allow us to assign values, doesn't allow us to mutate these values. So the only thing we can do is create this task at the highest level, and also the task cannot contain or cannot return any values. So the return type of our closure here should be void, which we cannot get rid of this one. So this one now compiles, and we might even try running it, but we'll run into an error when we're actually using the command. But let's just give it a go. So let's see how far is it. So it started up. Telnet localhost. The port's 8888. So we're connected. We can use the command create a user. Now let's see what happens if we only send this one. We'll immediately get an error. It's not because we don't have enough words, because I'll show you again. Say we have a create user full bar. We still get the same error, and the error is that we're no longer on the correct event loop. So by creating this task, we hopped to a different thread, and this file channel read function needs to be called from an event loop. So what we need to do is we need to hop back to the correct event loop, and that can be done using the context event loop execute, and then put this code here. And I think this should get us correctly into the outside of the back on the correct event loop. So let's see, we create a user full bar. We'll check in a bit. We'll create a user. That's not a well-formed sentence because it doesn't connect enough, doesn't contain enough names. So let's see whether this, it says the username is already taken. I don't think that's really the case. So probably when we're doing the first, we're doing the correct, not doing the correct check. So we're checking whether the username already is taken, whether we get back a nil value. And what we can do is, let's see, try loading data from file. Let's just make sure that we're not by accident already have a file there. That's unexpected. So we'll telnet into this one. We'll create a user. So it's trying to load data from file users.json. And now the big question is, does this file already exist? And this always means that we somehow need to find exactly where this thing is running from. And show the build folder, because that's the one where products debug. There's already a users.json file, so we can open it using Xcode. Oh. Let's see what happens if we create a different user. Okay, so we have our welcome food too. Apparently there already was one, and now it's already also here. So we're able to successfully persist data. We can go one step further, and but then we're going to stop for now, because there are still a lot of things to do. But one of the things we're going to do is we have the user. Now we can say our updated session dot player ID is the new user dot ID, and this way we will also get our session passed on through the responses. And let's just see whether we can print this one out, the updated session.player ID. So we should also be able to see now the player ID. Okay. One thing to note is that we can only create users so far. We cannot yet log in, but that's something for next time. Our biggest concern at this time is that we're now associating the session with the player. After creating a player, you're sort of immediately logged in. However, sessions themselves are not really persisted, because each time a new command comes in, we're going to the session handler, we're creating a completely new session. We're not yet keeping track of all the existing sessions and trying to associate incoming connections to existing sessions. But that's something for next time. I hope this gives an idea about how you can use asynchronous functions, how you can create a very simple backend. This piece of code is actually pretty reusable, and we'll add more to it because we have first, but we will also add filter and so on. So typical collection related, the collection related methods. But for now, this should be enough, and this one is pretty much reusable. Might even put it into a separate file. Yeah, so far so good, I guess. Thanks for watching and have a good day.